Hello folks. Today we're going to review a concept that may be familiar to you. That's the concept of money demand, but we're going to do it in a kind of algebraic way, and there's some distinct advantages to being able to do this. You'll be able to know more things. So let's just remember, you've already learned about the concept of money demand. How much of our wealth do we hold in the form of, let's say, currency, or also checkable deposits, what we use for transactions, and these are also assets that pay little or no interest. So what we learned is that when the nominal interest rate rises, the foregone income from interest-bearing assets also rises. So for this reason, it's the nominal interest rate that since it represents an opportunity cost for holding money, we hold less money when all else equal, the nominal interest rate rises. So we can see this as represented here by this downward sloping red line. Here we have real money demand on the horizontal axis. Here we have the nominal interest rate in the vertical axis, and here we have this downward sloping red line. Now, as you remember, that when output increases, money demand increases. Why is that? Because when there's higher output, there's also more transactions, and market participants will want to conduct those extra transactions by holding more money. So that's going to be represented here by a rightward shift of this downward sloping money demand curve from the solid to the dotted. In the other direction, if output falls, we'd have a leftward shift of the money demand curve. So we also have to remember that there are other reasons why the money demand curve might shift. We don't need to have a change in output. We're going to call these autonomous shifts in money demand. Here's an example. Suppose that we have a kind of a stock market crisis. The stock market, where people begin to worry about it, they think it's going to crash, and they're uncertain. So what they do is they flock to the safety of cash. And the investment advisor, might tell you, oh yeah, cash is king. Well, in that case, the money demand curve would also shift to the right, even though output is probably not increasing. But now we're going to do the money demand in an algebraic fashion. And the way we have this equation, that real money demand is going to be some function, or it's going to be multiplied. We're going to be working off what we like to call the baseline, or the natural level, the structural level, the baseline level. It's a reference level, and you'll see what we mean by that in a second. A baseline level of money demand, and we multiply that guy times 1 plus a bunch of other stuff. And what's this other stuff? Well, let's look at first of all, the output gap. This is the difference of output relative to potential output in percentage terms. And there's an elasticity here. And this is an elasticity of money demand with respect to output. We already told you it's positive. It's actually typically close to 1. So we'll be looking at numbers that are close to 1. Then here is our response of the money demand with respect to the interest rate. That guy is less than 0. It's typically not all that big, but we want to put it into our calculations. And you can see once again also we are calculating the nominal rate of interest relative to some natural or baseline level. Once again, that's going to help us very much in our calculations. And finally, over here we have a third factor, and that's the autonomous shifts to money demand that we just discussed. Now, this looks like a hairy equation. I can sympathize. But what we want to do is we want to break it out here. We want to look at all the stuff right here and here and here. And it turns out that this is just the percentage deviation of money demand for its baseline value. So the advice here is to start off with that, to calculate these 3 terms, and then add 1 to them and multiply the whole thing by your structural or baseline level, the natural level. So let's see an example of that. So here we've assumed that our elasticity of money demand with respect to output is close to 1. It's not quite 1, but it's close. It's very, very close. Here, okay, the nominal interest rate coefficient is actually negative. That's what we said. And there's going to be no autonomous shifts to money demand. So what we need to do, now let's take a look at our situation here. Now the situation here is that our output gap is greater than 0. It's 1.5%. Our nominal rate is exactly equal to that baseline value, so if you subtract that off, that's 0, so we don't even have to worry about that. What we need to do is multiply this guy times that guy, and it turns out that we do that, our percentage deviation of real money demand from the baseline or the natural level is 1.4%, so then we multiply that 1 plus 0.014 times our natural level of money demand, which we've assumed to be 1,000, and we get 1014.25. And that's our calculation for what money demand will be. Let's do another example. We're going to keep with the same numbers, but now we're going to reduce the interest rates. And since we reduce the interest rates and our response term is negative, that means we're going to be increasing money demand. So you're going to be subtracting this guy from that guy, and you'll get -2 and multiply that by 0.2, and you'll be bumping up our percentage deviation of money demand from 1.4 in the previous slide to 1.8, and now our money demand is a little bit higher. Why? Once again, because the output gap is positive, but also now because the interest rate is less than its baseline value. So we've provided you with some spreadsheets to help you do the exercise. You should try it. Thank you very much.